Hello, my name is Robert Smith and I'm with New River Community College's Academic Assistants. And today we're looking at the form of K. I know it's a little ambiguous of a title, but basically it's looking at how we can organize the equilibrium constants of two different formulae that are related to one another in such a way that they produce a relationship. So let's take a look at this. We've got the formation of water written in two different ways. We have it with two hydrogens, one oxygen, and two waters. Or we have one hydrogen, half an oxygen, and one water. So we're asked to write the equilibrium expression for each formula and how the constants are related. So K, I'm only putting K because I don't have the species here. Typically it would be in form of either all gas or liquid and gas or some combination thereof. Let's just assume that they're all gas for the sake of argument in this case. So we're going to look at products over reactants. So the concentration of water, gas squared, over hydrogen squared times oxygen. And if we're calling this all gas, you can easily call it pressure of H2O squared over pressure of H2 squared pressure of O2. So let's call that K1. K2 is very similar, except the exponents change. So K2 has H2O, H2, products over reactants, O2, raised to the 1/2, so the square root of O2. So pressure of H2O, pressure of H2, and then pressure of O2 to the 1/2. Square root of O2. All right, so how can we look at both of these? What is the relationship between K1 and K2? This one is kind of obvious, and typically you won't encounter a problem like this on a test, but it's worth looking at so that you can say, look at half steps or look at equations of formation and be able to rationalize why one has a different K than another, even though the temperatures may be similar. So we can say that K1 is equal to K2 under some circumstance, and that circumstance is when it's squared. So if I were to square K2, that would just be let's just look at this term right here. That would be PH2O squared over PH2 squared times PO2, first power, which is equal to that. And that's why we can say that K1 is equal to K2 squared. So this, again, comes into effect when you're looking at equilibrium constants in a theoretical sense for like the formation of different molecules and such. So keep it in mind. It will most likely not show up on a test, but it is a useful thing to know.